Okay, we are starting. I asked the audience if we are analog or digital, and you guys had told me that you are a mix. So SilabTech is a mix of analog and digital in the products and in the engineering that we have. So today, I'm going to talk about SerDes. It's one of our main products. We are doing high-speed SerDes. And I'm going to explain what is SerDes about, and as designers, what could be potential consideration for you when you're coming to select a SerDes for your application. We do have silicon-proven IPs on TSMC, Global Foundry, and SMIC. And we are a very dynamic team. We are customer-oriented, and we are here to support you. So stay tuned, and you will see what we have to say today. So first, what is SerDes and how this magic is actually working? SerDes is short notation for serialize and deserialize. If you can see at the diagram below, there is explanation of what is SerDes. We have a parallel bus with element that is called serialize. It's also taking the data in a parallel format, serialize it, and pushing it from a transmission side to the receiving side on a differential lines, on two wires. And this is all the magic. You take a lot of data and push it very fast on two wires to the other side of the link, which is the receiver side, who is doing another function, which is to deserialize the data and to reconstruct it into its original shape. And all to extract out the clock. So if you can see, there is no clock in between. There are only two wires. So the clock is being encoded inside the data to the other side. And why all of this is becoming now so popular? Because there are two major savings. The first saving is at the silicon level. We are saving a lot of I/O space and silicon space by using this technology. And second, on the PCB and the system level, we're saving on the cabling, on the PCB area, and on the onboard interconnect. So if in the past there used to be a lot of parallel lines on the PCB and many hours on the PCB editors to actually make these buses work, today we are doing the work much faster with serializers. I will review today a few applications where SerDes are popular. PC, servers, mobile devices, data converters, and debug. Since you guys, I see some of you designers, you will be very interested to hear about the debug options of using SerDes. Okay, so we are starting to run. So we said PC and peripherals. The most commonly used SerDes is the USB, Universal Serial Bus. Started at the 80s. Started at the 80s, and today we are with USB 3, full duplex, 5 gigabit per second, and 3.1 is already out with 10 gigabit per second, full duplex. And designers wishing to select USB SerDes from an IP vendor would like to look on two major selection criteria. One is to make sure that the SerDes that you are considering is not only silicon proven, but also tested by the relevant standard body. And according to this standard body instructions. So we are testing our USB according to USB implementation form, which is known standard body. And you want to see that the USB 3 super speed is actually pass. The next thing is to consider when you look on USB 3 is to look on the implementation of it. USB 3 is implementation where the wire is actually free at the air. And this means that there is a risk of ESD. So you want to make sure that your SerDes is including the option to have an ESD cells to protect the SerDes itself and the inside circuitry. We do have ESD cells accommodated in our design. Next thing is server and communication equipment. In these applications, we do have a lot and very large motherboards and backplanes. We need something else. The requirements are high-speed links, low power, and since it's a high volume production, we want it also at a very low cost. That's why we are looking for a standard that will support multiple markets and also include all of these requirement and address the requirement. We have PCI Express Gen 3, which is 8 gigabit per second, and we have today PCI Gen 4, which is 16 gigabit per second, SerDes. They are addressing those challenges. Now, what could be selection criteria for PCI SerDes? One of them is to make sure that the SerDes can support multiple lanes. In PCI, you have multiple lanes that you need for different applications, if it's a GPUs or other modules. Each one of them will consume different or will require different number of lanes. You want the SerDes to be able to support these multiple lanes. The other thing is to make sure that your SerDes common module is not repeating itself again and again with every lane. In our case, we can support 8 and 16 type lanes on one common module. I will come back to this later, but this is the standard application, large motherboards, many slots, either in a rack or in a single PCB. Next application that is coming common today is the MIPI, the mobile interface standard. So today, smartphones are becoming very sophisticated. A small piece of PCB has multi-megapixel camera, high-definition display, couple of RFICs dealing with all the different bands around, and a few sensors. All of them need to communicate at a very low power because they are battery operated. There is a standard around that was created by the MIPI Alliance, which is trying to address commonality in the interfaces. This is the MIPI. So you can see here how the MIPI address all the different interconnects and addressing the low power, the EMC resistance. As I mentioned, there is quite a few different frequencies and RFIC on board, and a very short distance, high-speed chip-to-chip communication. So the standard is defined as a D-PHY, C-PHY, and M-PHY. This is as of date. And there are different controller levels that are addressing the different communication schemes. What could be selection criteria here? We are talking about SerDes that will enable, that will have embedded low jitter PLL and noise filtering LDO. This is to make sure that the communication is smooth with the minimum interruption from the surrounding area. Remember how small it looks. All of this is running there. And the second thing is to make sure that the SerDes is compliant to the latest standard. At the SilabTech case, we are compliant to the latest standard. And this is a typical application where an M-PHY, which run up to 6 gigabit per second, is being used to communicate between a sensor, camera, and host processor, and another PHY is being used between the display, high quality display, and the host processor. And if you can see, this is our silicon result. It's always important to select a product that is silicon proven. In this case, I can show you here a GF28 SLP, super low power. Remember, it's all about mobile and a low power at the different speeds. And this is how the silicon look like, and this is the image of the silicon. So moving to the next application. We are at application number 4. We have 2 to go. High resolution data converters, ADC and DAC. So before getting into this standard, I want to see where this standard is coming from. So today, the data converters are being designed to run very fast. We have data converters of analog devices and linear and other vendors running at 500 meg, 1 gig, and up to 2.5 gigasample per second, which each sample is 14 and 16 bits, which means they produce tons of data. Now, this is an off-chip device that need to communicate with the host processor or with an FPGA at these rates, which is above the 10 gig per second. So these companies came with a standard called 204B, which today is defined up to 12.5 gigabit per second, and is addressing the market of the data converters for sensors, radios, and other industrial application. These devices will have a built-in SerDes. So when you buy it, you don't need to worry about it. However, if you want to integrate it to your SoC, you need to take care of the receiving part at the SoC. And you need also to consider the controller side. So we at SilabTech have a complete design which is based on a tile design. In these applications, you'll find that you'll need sometimes many receivers and no transmission at all, or the other way around. You need a couple of transmissions, TX blocks, but no receivers at all. So we can offer customers this mix of RX and TX together. We also offer the controller, which is a digital layer that's sitting on the top of the analog SerDes to make sure that the SerDes is behaving as we really want to wish. And of course, this is our silicon result for this. Some colors. We need some colors here, I think. So what we see here is a result of 12.5 gig SerDes running on TSMC 28, HPM, and HPC. And what you want to make sure is that the opening of the eye is really someone that is really wake up, yeah? The eye is large on the vertical side, it's large on the horizontal side, and there's a clear definition here. Good. Next application. Designers, remember, when you have an SoC, today the SoCs are very complex. So if we have SoC at 28 nanometer, we have more than 100 different IPs on board. Quite a few processors, memories, interfaces, and many others. Now, the challenge of the designers today is to be able to debug these SoCs. Now, what we are offering here is we are offering for designers the high-speed serial trace port, which is essentially, this is a TX part of our SerDes located on the chip, and with internal mocks, designer is being able to trace different address and control lines. And the TX is really transmitting everything out on 2 pins that is being dedicated for this. Of course, later in production, these 2 pins can be part of the JTAG chain or could be used for other purpose. But for debug, this is essential part to have an independent channel that is actually transmitting everything out, and you can select what you want to get for your analysis. So in this case, the SerDes is actually transmitting everything, so there is no clock and data skew problem, because this clock is embedded into the data. And we have a significant reduction in the number of pins. If in the past we had to take all the 8 or 16 bits out, let's say using 20 pins, now we can take it on 2 pins. And what could be selection criteria? So selection criteria here will be on how easy is to integrate a SerDes IP into your design. I will not touch too much about it because tomorrow morning, 11 a.m., I invite all of you to come here and to meet my colleague Ravi. He will discuss in details about interfacing SerDes to the SoC. This is a summary table. Just before we leave for the day, I want to make sure that you guys capture. We discuss about USB 3 and PCI Express. We discuss about the MIPI for mobile applications. Check out MIPI.org. This is the standard that you should look for. We also do, with our multi-standard SerDes, we also addressing the SATA and the new standard for HMC, the hybrid memory cube, which is was written and published by the HMC forum. Another application that we are addressing with our SerDes is our data networks and a backplane-based Ethernet SerDes. This is the 1 gig, the XAUI 3.1, the OIF, optical interface form, different standards, and the Cisco standard, which is the SGMII, and the quad SGMII. This is very important for all of you that are dealing with a backplane connectivity, which you need up to 1 meter SerDes communication, plus considering the insertion loss on the different connectors on the way. We also discuss the 204B. We discuss the trace port. And last one that I just want to mention is the V-by-1 and display port. We're also giving solution to this. So to summarize, SerDes standards today are getting evolved with the different technologies and application. We at SilabTech are continuing to develop SerDes technologies to address these advanced and emerging technologies. Our designs are in advanced nodes, 28, 40, but we do also give solutions for the 90 and 130 nanometer solutions. Our IPs are silicon proven. We can show silicon results, and you are welcome to stay here and to talk with us about our IPs. And we also offer customization to your specific need and specific application which are out of the standards. Thank you very much for being with us. I appreciate that you stayed, and thank you.
Thank you, Yossi. Very nice, very nice. And yes, question. Sure, go ahead.
Do you plan to develop 56 gigabit PAM4 SerDes as the next step?
Yes, so we have a conceptual design for advanced SerDes, and it's just a question of getting support from customers. So we're looking for partners to discuss with us any future type of high-speed SerDes. The 28 and the 56, you're welcome to stay to talk with us. It's there. Thank you.